press the button that makes you a co-presenter.
So tell me what I need to press.
Well, something should pop up in your screen that says, what?
There?
It says, wait. It's going to access your computer with any luck. Yeah, I guess you do.
Do I want to run it?
I think so.
I suspect I do.
They're pretty safe.
People enter the page.
No.
That would be nice.
This one is not, but the talk that I'm going to give on Thursday, I've got it at box.net. I could put it there. Now, is it file cabinet or something else you have to set up?
I know there's some, I don't know, the only thing next to the file cabinet, file holders,
Oh yeah, we're doing. Are you saying where to download things from?
The files you want.
Yeah, we're posting them on the web as we get them.
Okay. Oh, so I need to give you the file.
Right.
Okay. So we'll make sure.
Yeah, I love your stuff.
Huh?
I love your stuff.
Oh. Thank you.
Okay, something
So let's see.
something is missing here though. You're.
I can close this now.
Oh, you are a presenter, but I don't see how you need to see. Yeah, don't close it, but you can minimize it.
I mean, minimize it, yeah.
Now, press the Share Desktop button at the top. Share Desktop at the top.
Okay.
And then everybody sees your screen.
That's it?
That's it. It's on.
Okay. So I'm going to open up Stellarium. This is 10.2 that I'm using here. I've tried up to 10.5. On this computer, it doesn't run very fast. So 10.2 runs nicely. And that's the one I recommended to you. And let me just I'll get it up here, then introduce just a bit. Okay. So on Thursday, I'll be doing a talk about the curriculum that we've created for Universe Quest and the Oakland middle school after school program for young women. And in that was about 3 years ago when we started that. And in that program, I was fortunate to be referred to Stellarium by Rosa. I was using what's a Starry Night at one point as a planetary program, and I understand we're going to hear about some other programs. But Starry Night costs a bit. We were looking for something that didn't cost something. Rosa mentioned Stellarium. She says you use that. I got a hold of that and now love it. I use it regularly. It's a free download, as I've indicated on the sheet there. And so we built some of the Universe Quest program curriculum around Stellarium, some around Solstices, some more independent of either one of those. So the things that I plan to present in this workshop here are not specific things that I've used or we've used in Universe Quest, but things that as I've kind of learned the program, I've kind of played around with and kind of tested it out to do different things other than just look at the night sky, which is lovely in itself. And I use Stellarium to plan observations on a given evening with my telescope, see whether the moon is full moon or quarter phase or whatever it is. So that's a very nice aspect of it. And I can look into a month ahead or 3 months ahead or a couple weeks ahead and those kinds of things, which we'll see. These three applications, and I have till 10:30. Is that right, Alan?
Yes.
So I'm hoping to get through the first two. Maybe I'll just kind of hint at the third one. But the first one's relatively simple. The second one rather involved. The first one looking at the orbital period of Jupiter's moons. Second one measuring the distance to the moon using parallax and using data off Stellarium. Some of you know who've been around here for a while, parallax is kind of one of my pet topics, and I like to do things with parallax. So I was looking for something with parallax and Stellarium. Also kind of testing out how accurate Stellarium is in terms of its quantitative, its data, the RA and DEC, and the measurements that it indicates on on the screen. So looks like it does a pretty good job. And then finally, a relatively simple activity using the positions of the sun during the day to give partial explanation to the seasons. So I hope that at least enough of you have Stellarium up and running so that you can at least see a screen, you can see somebody else's screen if your computer doesn't have it. How many of you have Stellarium running right now? Like, oh, terrific, that's great. Okay, some of you, how many have used it fairly regularly already? So I'm wondering who am I talking to? Okay, a lot of you. So some of these things we'll go through quickly, but I want to make sure that those of you who are new to it have some idea. I'm not intending during this workshop to teach all the details of Stellarium. I'm looking at the specific activities here, and I think as we go through the week, other people will be talking about that. So the one thing that you need to know to start up, as you start up your computer, Stellarium will start up and put the sky on the screen. That is the date on your computer. Okay? Yesterday I reset the time, date and time. So I reset my time here to Wisconsin time. So I'm 2 hours different than what I'm used to in San Francisco, which is where I'm from, that area. I still have it set up for San Francisco sky. So this sky is actually, let's see. This gets very confusing. The part about time and so forth, it's like San Francisco sky, but the time that is on it is incorrect. Something like that. So the first thing we're going to do is I'd like you to go ahead and, because this particular activity doesn't depend so much on activity, on location, but just so that you know, location window is over, the two menus are over on the left and down at the bottom. We'll just pull your screen down there. And then actually what I'm going to do is, no, this is okay, like this. Go over here to the top icon, location, and I'm going to shift this to your keys. So the time on my computer would be consistent with the location. And interestingly enough, it also has to be consistent with not only the time you put on your computer, but the time zone you put on the computer and on your setup. So it's a little quirky in that way, or maybe it's not quirky, but you have to figure it out. So I'm just typing in with this little magnifying glass your keys. Now, if you haven't, maybe 10.5, I suspect that little icon for typing it in is down here. Either way, it's pretty clear. It's on the bottom. Yep. You find that little magnifying glass. So your keys, KES, and then your keys comes up. And you click on that, and that's all you do. You just close it. Now, if you want to have that as your default, then you click the little box down here. But if not, I'm not going to use it as default. Actually, I am going to use it for default. Now, I'll go back to
Is it okay to interrupt and ask a question?
yeah, okay. Too many?
Okay.
Sure.
So is your team just in their database? No.
No.
Oh, okay. View it.
Yeah.
But you can enter it if you know the longitude and latitude?
Wait, what was your question? Is your keys what?
It's not in the database.
You said we typed in your keys and it just popped up.
Yeah. The rest of them popped up, yeah. You just need to type in as much as...
It is called the database.
No, it's not in the index. It's in your index.
Oh, I see. It's in my index because of...
Give us the last long. And
You're right. Okay. I forgot that. So you don't come up with your keys.
No.
Okay. So
What's the latitude?
as far as I'm concerned, for this particular activity, why don't you just click on the U.S. maps right there where or is it roughly?
Milwaukee.
Click it.
Milwaukee.
Milwaukee's
Whatever
pretty
comes
close.
up. I mean, yeah, you probably could type in Milwaukee and be fine, or I don't know. I don't think
Christine is on your RACINE, and that's probably...
Really? How do you rate?
just want to get a location close.
RACINE.
It's okay too. If your computer is set up for European Union time or China time, that actually for this first activity will be just fine. Okay. So we need, I'm just basically showing you how to get a location. You can close that. So now, for this activity, we're going to set it up so that we're going to look for Jupiter. Okay, creating Jupiter's moons. And so you can follow along here, but once you've got the location, then you come down here to the lower menu, and there's a little icon that probably is lit right now. This is brown. Take that off.
Can I make a comment?
What?
Can I make a comment?
Sure.
Usually, when I train teachers on the use of Stellarium, the most confusing thing when you are setting the place where you are, we will that's got clear to everyone. There are two different things. One is your home, and you say, that's my default, this is where I live. And the second is like what you've done now. For instance, my hometown is Lisbon. And when I take Yerke, it will give me the sky in Yerke as the time in my location. So if I say it's 2 p.m., it's 2 p.m. in Lisbon. I see the sky in Yerke at 2 p.m. in Lisbon. Not 2 p.m.
Right.
That's
Right.
We're
going to get to that when we do the second activity. That part of that, for part of that reason, I'm having you take off the ground. So there's not going to be any ground reference on this. I want you to take off the atmosphere. So what that does is eliminate any scattering of the sun. So basically, it looks like nighttime, whatever time it is in the day. And finally, one other correction. So you see the screen now comes up here. This is the Yerke sky right now. That is without the conflict of the sun. And finally, come over here about 3 icons to the right. It says switch between equatorial and azimuthal out. That one we're actually going to click on. Normally, I think the default is on the Alt-Az.
Alt-Az, yeah.
So click it on equatorial, and that's going to keep, later on, it's going to keep the view of Jupiter fairly horizontal instead of looking like this as it goes down. Those of you who work with telescope regularly know we've got, Jupiter, which way is east? Over here somewhere? It comes over here,
Southwest.
something up like this, and like this, and like this, and like this, and we want to keep it relatively horizontal. Okay. Now,
How do you know whether it's unequatorial or not? Should it be lit up or not?
it should be lit up. The equatorial? It should be lit. Yes.
The little telescope should be bright.
By the way, I need to say this every time. I'm hard of hearing or hearing aids. There seems to be kind of a bounce around here in the room, so I'm having a little trouble hearing. I've got an appointment to get some new hearing aids, and they're going to be perfect, right? But meanwhile, so there we are. We're going to set the date now to, the time. So it's the second window down, icon down. So I think I said January. Many of you know.
You went January 15th?
Back in January is when Jupiter was up, right? So we're going to go. We've got this current date. I'm going to go back to 1 and set it to 15. All you need is a date when Jupiter's up. And then I'm going to set this for here, I think I would have said 18 hours, 17 hours, 1900 hours, 7 p.m., 1900 hours. Now, Jupiter is over here kind of on the right. You may not have the ecliptic on yours. Again, I'm not going to add all these various lines in here. Here's a meridian, here's the ecliptic. It's possible those aren't on your screen right now. But you can find, if you can't find Jupiter, go over here to the 4th icon down, search window, click it, type in Jupiter, and all you need to do is about 4 letters, and that's the only one it reads, and click the magnifying glass, and it will find Jupiter. You can do that with any location, wherever your computer is set right now. And I'm going to pull this up to this. I want to keep the time out here, but I want to get it over Jupiter. So if you were just finding Jupiter as opposed to using the search, you'd click on Jupiter and you get some information up in the upper left window, and you get these little red lines indicating that's the focus. At this point, I want you to click the space bar just once. Now you didn't see anything happen here, but let me show you what it does. If I take Jupiter over here and click on it, and click the space bar, it pulls it right into the center. And that's going to allow the software to track Jupiter regardless of the time, because we're going to be changing time. And if you didn't have that centered all the time, you'd see Jupiter go up to the right of the screen. Okay. Set so far? Okay. So, want to magnify Jupiter? If you have a mouse, you can just roll the mouse, and you can zoom in and start to see the moons. If you don't have a mouse, use Control and up arrow, and just bring it in, zoom it in as much as you want. And I would recommend bring it in about like that, so you can see the planet pretty well. Okay. Io, Europa, Ganymede, Callisto. Huh? Callisto?
Yes.
Callisto.
No, Callisto.
Callisto, that's what
Rich, any way you say it is okay.
Okay, it's Callisto. Good. Okay. And it's Io.
Io, or Io.
No, it's Io. Okay. The next step, I'm going to insert the next step. It's actually the one at the very last on the next page, page 14. This is something that kids love to see. I mean, not just kids. We can speed up time here rather nicely just to see these moons orbiting. So if you go down here into the bottom menu, far right, there's a double-headed arrow. If you click it once, you probably won't see much of a change. You're going to see the seconds on the time clock there change. And by the way, you're seeing this change. You're not seeing any change up here. This is going to stay the same until you actually go up here and change this. But these controls change this.
Controls at the bottom.
Click it again. You might start to see some movement there. Click it a third time. And if you want a fourth time, but don't go a fifth time unless you want to get things totally out of control. Well, maybe you can go forward. I don't know. There we go. And if you clicked it too many times and it's really, going way out of control, click the little, what would that be, forward, click it there, and then just start over. I can basically stop it with that. You can go back again if you like. Yeah, you can see how we've already gone into February 8th by letting it run like that. Yeah. But this is kind of nice to just see the motion of the moons. The fact that we have the equatorial mount set means that you're seeing it constantly in the same plane, like you would want in a photograph. Keep it in the same plane rather than having that field rotation in the image. Okay. Questions so far? Okay, so let's stop it there, wherever you are, and go back up here.
Question.
Yeah. Oh.
Why don't we see the sun moving? I see mine.
You don't see this moving.
Yeah, but I see mine.
This doesn't control that. This controls the time down here. And as soon as I touch one up here, this is going to change dramatically.
In mine?
In my
Oh, you're changed?
Yeah.
You have 10.2? Different version, yeah.
I'm going to love it.
So the newer version, they decided to change that.
Yep.
There's always good reason for coming out with a new version, like
To
Like
confuse
driving
people.
more advertising.
Yeah.
Driving you mad.
Okay, so go up here and change it, and then change it back to the 1900 hours. Okay. Now, we're going to focus on Io, and I think, at your leisure, you can do some of the other moons. We'll just do one example of Io. I want to measure the time that it takes for one full period. And I need some kind of a point here. Now, I'm sure some of you can come up with other ways of finding a reference spot. This is my way of doing it. I'm going to change the time here manually in the hours. I'm going to go 19, 20, 21, 22. 22 is a little far. I'm going to back up, and I want to get I.O. as close as I can to the middle of the planet. Okay, and that's where you're going to introduce a little bit of error, of course. But if you're willing to follow along with me on that, I'm just going to move now the minutes. I.O. is slowly moving toward the center. And, I don't know, roughly about there. Something like that. And I'm going to note this time. January 15th, 21 hours and 41 minutes. And your times could be different, right? Slightly differently, however you decide to adjust I.O. So we've got an initial time, starting time. And now you can probably, are we all together on that? Everybody got a starting time? You can record it here on the paper. So now you can probably guess what we're going to do. We're going to change the time, move it forward until I.O. comes back again to that particular spot. Pretty simple. So I'm going to increment hours, make it go a little faster. It's going to go out to its most extreme point, and then start to turn around. Meantime, the other moons are moving.
How do you know it's faster than the
You don't know exactly. You have to just watch for I.O. Tom, you got me mixed up.
Anytime.
I'm just trying to get I.O. right back in the middle. You probably could. Is there a way that your version does that?
No, I mean like...
Oh, just physically?
Yeah.
Okay. I guess you could. You could also probably, use it when it just hits the edge on one side or something like that. Yeah, so, you try different ways. You could also probably bring on I didn't turn on a grid, but I've got, now that's the Altaz grid. The deck grid. See, there's the RA deck grid that I just put on by coming down here on this. There's the equatorial grid. I could probably use that too. Okay. All right? Okay. However, the way I'm doing it right now, this is the first way I think I figured out. So I went a little too far, so I've got to back it up with the minutes. Back it up till it gets to the minute, to the middle. And out there, for me, I've got another time. It's now the 17th of January, 1619 minutes. So you can record that time. Yes, like a quarter period. So, or it turns around and turns around the other side. Over here and over here. Sure, and then double it. Did you all get that? Like when it hits an extreme and it hits an extreme, that might be a little hard to tell exactly where that is, but yeah, why not? I mean, here's where you as teachers and working with the students, say give them free rein. Say, they know this software now. Figure out a way to measure and come up with two or three different methods. Maybe decide which one you think is the most accurate, that kind of thing. So do a little calculation of the time and see what you come up with. And what's amazing? Huh?
That touching the edge thing, it seems like we can get it within a few minutes. Replicability.
Oh, I think the capability is quite good for, yeah.
I was looking for
Another file here that I've got some results on it. What'd you come up with? Hours? 43? Yes. Okay. Anybody, 42 hours and how many minutes? 27? Okay. Well, this old textbook that I always refer to, looking up data and so forth, it seems to give I/O in days about 1.77 days, something like that. So you figured out, and around about 42 and a half hours is about the right number. Yeah. So Patrick and I guess Kevin is noting the Rimmer's early experiment with Ole Rimmer, measuring the speed of light with the time of the moon coming behind Jupiter. So how would you take that into account here? I'm not quite sure. I'll leave that for another exercise. Let's see. So yeah, I got 42 hours, 34 minutes, about 1.77 days. I think it's 1.75 days or something like that. So it's quite close. It's very close. And I did Europa later, and I got about 85 hours and so forth. I haven't done the last two with this method, but what I'm telling you is that it seems to be, the time and the distance and the the scale on their Jupiter Moon system seems to be quite good in terms of time. Yeah.
I think when you have the students do it without a grid, and you just give them a starting point and see where they end, you know that your group of students are going to have different values.
Yeah.
And that fits into the scientific inquiry, the situation that scientists can be looking at the same event and come up with differences, uncertainties, and that's where that uncertainty comes in. And that's where you have to have a dialogue and find out. When it's off by a day and everybody else is on something else, then you've got a way of self-correcting yourself. And that's an important process, I think.
And have the students discuss, I think my method's better, no, wait a minute, I think probably method's better, or why, and, where are the inaccuracies.
More than one method to be able to verify the fact that your data.
Here, I'm just eyeballing the center, and, I possibly could blow it up a little bit more to get a little more precise. See, that's way off now that I see it going up.
But still,
Okay, can we move on? All right, how are we doing? Wow, 10 minutes. Okay, well,
Time flies.
distance of the moon using parallax. So, there's some background here that I certainly don't want to spend time with given the amount of time I have left here. The idea of parallax, I hope most of you know the basic idea, but the simple one to start with is holding your thumb in front of your eyes and going between the two, switching between the two eyes. And if you haven't ever done that, do it right now. And you see the thumb appear to move against the background. And not only that, as you hold your thumb closer and closer, it appears to move further and further. We call that a parallax shift. Okay? So in astronomy, if we take a photograph of an object against the background of stars, and we take it from, say, two different places on the Earth, and we see that object move a little bit against the background of stars, it's a fairly nearby object, as opposed to trying to get parallax of a star against further stars. If you've got a satellite like Hipparchus that you send around the Earth and it can measure, 0.001 arc seconds difference or something like that, then you could probably get a little parallax. But basically, we can't really, that's very difficult to do. But the point is, nearer objects have more parallax than further objects. The moon is an example of a relatively nearby object, astronomical object for us. And so I was thinking, well, I ought to be able to use Stellarium to view the moon from a couple of different places on the Earth. And I actually started out with San Francisco and Paris, since I was in San Francisco, and they're kind of at the same latitude, not quite, I don't think. So I was thinking, well, that would be convenient. But then it was hard to get a real good, without getting into some little bit of trigonometry and maybe some spherical geometry, I don't know, to find the baseline, the direct baseline between San Francisco and Paris. So I decided, well, why don't I go to the equator? And I originally picked Quito, Ecuador, which is practically right on the equator, and the other side of the Earth. Whatever, there was a place in Indonesia, I believe. I said, well, okay, so I know the diameter of the Earth, so that'd be a nice baseline. And I tried to do a calculation and realized, wait a minute. You can't see the moon from Quito and the things on the other side. Right? You're looking straight out. They're parallel.
Just want to say, for people online, Rich is holding a ball and pointing to different parts. We don't have a video of that.
I'm holding a blue ball of the Earth. It has Quito, Ecuador, and the equator. So, thanks to knowing Susan, I decided, hey, let's use Nairobi, Kenya. And it's practically right on the equator too, right? So I've got a couple of spots. These are not to scale. I think Nairobi should be over here a little bit more. But, so picture, well, let's do it this way. Picture a telescope here, looking up at the moon, way out here. And we'd have to figure out the scale, but it's a significant scale, significant distance out.
30 times Earth.
How many Earth's diameters out
30.
30?
Yeah.
30. Okay. So take this out 30. That's maybe the top of the ceiling then, huh? Something like that?
30 times Earth radius.
Okay.
Or diameter.
That's right.
Diameter.
Newton used that, didn't he, in calculating that gravitational force. Okay. So we've got a parallax angle. If you can imagine taking pictures from the equator, from these two spots, at something maybe on the ceiling here, but then the stars are in the background. From this telescope, you'd see it over that way. And from this, I'm exaggerating, from this telescope, you'd see it over that way. And you could, if you had two nice photographs, or one that you could combine, you could actually measure that parallax shape. So, and the geometry is relatively simple, represented by this little triangle diagram. Isosceles triangle, basically. You're trying to measure the distance, large distance D. You've got these 2 points, A and B, which are going to be Quito and Nairobi. Have to calculate that baseline. But then we can measure this parallax angle using Stellarium. Parallax angle P, and then there's a simple equation down at the bottom that you can use. So, here's where we're going to make a little shift in our Stellarium. I'm going to move it back away. By the way, you can use the backslash key to, mine's not functioning right now, but let's see. There we go. Hit the backslash key once or twice, it'll zoom it all the way back in. Okay, so we're going to go to Quito. Let me see if I can follow my own directions here. We're going to turn the ground back on, and the atmosphere back on. Keep the equatorial on there. Okay, now we're going to change to basically current date, and I'm going to go up here again to July. Well, not today's date, but I just happen to pick the 15th, so let's use the 15th. I probably have some reason for using it. Oh, I know, it's roughly a full moon. That's why I picked the 15th. Okay. I mean, you could use any phase of the moon, just use the edge as a notation, but I picked a night on the full moon. And then I'm going to go to 1800 hours. And here I am in your case.
Oh, you're doing your case?
Well, I'm in your case, right?
I'm in Quito.
Okay, so here's where this issue of time and place come into play, all right? I'd like you to, because we now have the ground, you can find where the eastern horizon is, roughly, where the moon is going to come up. Okay? And so I want you to, wherever you're located, the Stellarium right now, if it's daytime, fine. If it's nighttime, fine. But I want you to increment the time either up or down. And in my case, I have to go a little bit later. Wait a minute. Let's see. Looks like the sun's not ready to come up. No. Okay. I'm going to go later until the moon comes over the horizon, which it's starting to do now. And I'm going to take it one more up. So I've got the moon just over the eastern, kind of southeastern horizon this time of year, full moon. How are you doing? Are you with me? Are you still incrementing? Okay. Now keep in mind, while the moon is coming up on the eastern horizon in Quito, wait a minute, I didn't change this to Quito. That's the problem.
Yeah.
I was wondering about, okay, let's get to Quito. So Quito is definitely in your, you probably did that, and I said it, but I didn't. Okay, Quito, Ecuador. There we go. That's going to be. And you can go ahead and close that. And now, got to kind of work things around. I'm going to back off the window a little bit. You know, probably so that you don't get totally disoriented here, let's take off the equatorial mount. So we've got a horizontal horizon. Did you understand what I was saying there? Take out the equatorial mount. So now it looks more like what
Alt-azimuth?
Alt-azimuth. Alt-azimuth. That's what you want.
I want all that, yes. Okay, so we've got the moon coming up in the eastern horizon. Keep in mind that meanwhile, in Nairobi, Kenya, and we're going to go there in a second, the moon has gone across the sky and is now starting to set. And we'll look at that in a minute. What I'd like you to do is click on the moon. Okay, we're running out of time here, and so I'm just going to indicate this, and hopefully maybe during some free time or something we can continue this. By clicking the moon, you go up into the data about the moon, and you've got an RA and DEC. And why don't you go ahead and record that? I had, because I'm moving fast here, I had also meant for you to record the longitude and latitude of Ecuador. You'll find that the latitude is almost 0, and the longitude is, I don't know, about west 78 or something like that.
Yeah, west 7830.
Okay, well, so you might also record that. The longitude for Quito, that's number 2, is west 78, what did you say, Tom?
West 78 degrees 38 arc minutes.
Okay, west 78, 38. 38? 78, 38?
30.
30. West 78, 30 minutes. Okay, so you've got an RA and a DEC, 2019. You can round it out to 2019 or 2020, and the DEC is negative 1628. That's all the information you need right now, except that I'd like you to notice the location of the moon relative to Capricornus. If you don't have the diagrams or the outlines of those constellations, they're down here in the lower left menu. You can click on constellation lines. I just took them off. I can click back on. You can put the name right here. And if you want to get really jazzy, you can click on the figures too, but that kind of takes away from what we're doing right now. A little complex on the screen. But notice that the moon is just almost touching that line. Okay? Right at this point. Now, without doing it quantitatively, let's switch to Nairobi. Type in Nairobi. Nairobi, Kenya. Click on it. You can go ahead and close that window. Now, you've got to find the moon. You may be able to just scan for it, or you can just go search moon. Whoa. Wow. Okay, so it's over here. It's kind of starting to set, but it's still a ways above the horizon, the western horizon in Nairobi.
I got a tree line.
Click on it, you get RA and deck information again. Notice that the deck is practically the same as for Quito because they're both pretty much right on that equator.
Convenient.
The most important thing to notice in terms of this presentation is notice the moon's position relative to that line on Capricornus. It's significantly shifted. It's easy to see that it's in a different position. So if we were able to, talk to someone in Nairobi while we're in Quito or vice versa and say, well, where are you seeing the moon right now? Here in Quito, we would say, well, it's practically right on that line of Capricornus or right on that line, even though we're not going to see the lines in the sky. And Susan in Nairobi is going to say, well, no, it's quite a ways away from that line. Well, that's parallax. And using the differences in RA, all you need to do is subtract the differences in RA because we're right on the equator. You can get the parallax angle. And then you do a little bit of geometry, which is not terribly complicated with the diagram I've got on the board there, using latitude and using longitude. The angle between Nairobi and Quito is around 115 degrees. That's easy to calculate. Just add up the longitudes. So you can use a little. Some of you may remember way back there's a thing in trig called the law of cosines. That's the one I used in this particular activity. If you use the law of cosines, of two sides at an angle, you can get the third side. That's the baseline for the parallax, and do your calculation of distance. And you'll find that the calculation is very close to the published numbers, which to me was rather reaffirming that the accuracy of Stellarium is quite good. So I think, given the time, we better.
Just for the record, perhaps you could scroll down your activity sheet for people that are online and
there's another activity.
Okay.
We're going to post the activity sheet. It's not up online yet.
You know what? I can do.
You can just
I think we ought to do the break, but I can go ahead and just do that right now.
do what?
Well, what Rosa suggested.
Just scroll down.
Scroll the activity sheet.
That
Yeah.
are online.
I've got to find the activity first.
The look of your activity.
Here we go.
And during the coffee break, you should just coffee free. Everyone should be coffee.
Yeah, for those online, this is the diagram I was talking about. Moon. Points A and B would be Quito and Nairobi. Parallax angle between them. And then we went through looking at the data of the moon from Kenya, from Quito. Longitude, latitude, RA and deck of the moon. And then from Nairobi. And then we do a little calculation. We have to do a calculation of the baseline, which involves cosines. And there's a lot of cosines. And now we do a calculation. And calculation comes out to be about 390,000 kilometers. There's a little bit of an error because error in the full measurement, because we're measuring from the baseline to the moon and not from the center of the Earth to the moon. The center of the Earth, so there's a little error. You have to add around 3,000 or 4,000 kilometers to make it a little more precise. Okay, thank you very much.
Thank you, Rick. But it's a 15-minute break now. Let's make it 10, if that's okay. We get slightly back to schedule.
What do I need to do here, Alan?
You can, I actually just stopped your sharing. You don't have to do, yeah, you can leave the meeting. Control with that. Unless you want,
Let's jump in. I don't need to stay on.
you know,
I won't.
and it's
I won't be presenting until.
I'll put it on the astro.
Thank you. Please stand by.